Introduction of cache memory. Cache memory, also known as cache, is a supplementary memory system that temporarily stores frequently used instruction and data for transfer processing by a computer central processing unit (CPU). The cache supplement and extend a computer's main memory. The external RAM (DOM) access memory (RAM) that use semiconductor-based transistor circuits are used in both main memory and cache. Cache store a copy of only the most frequently used data or program code from the main memory. The smaller the cache capacity, the less time it takes to locate data within it and provide it to the CPU for processing. Cache memory is the fastest available memory and serves as a buffer between RAM and the CPU. Every time the processor needs to read or write a location, it checks whether a corresponding entry is available in the cache, reducing the time required to access information from the main memory.
Hi, my name is Nana Dramini Omar from PP. I will talk about memory hierarchy. Memory hierarchy design constraints on a computer's memory can be summed up by three questions: how much, how fast, and how expensive. There is a trade-off between capacity, access time, and cost. Faster access time, greater cost per bit. Greater capacity, smaller cost per bit. And the last one, greater capacity, slower access time. The way out of the memory dilemma is not to rely on a single memory component or technology, but to employ a memory hierarchy. Now, I will introduce you to a memory hierarchy diagram. As you guys can see, at the top of the pyramid, we have level 0, which is CPU. Next, at level 1, we have cache memory and continue with level 2, which is the main memory. Next, at level 3, we have magnetic disk. Lastly, at the bottom of the pyramid, we have level 4, which is magnetic tape. Let's go. Now, I will brief about this diagram. Further up, the cost per bit increase, access time will increase, but the capacity will decrease. If the capacity increase, it will lead to a decrease in access time. In addition, the higher the level in the pyramid, the higher the frequency of the memory by a processor.
Next is the principle of cache memory. The cache contains a copy of portion of the main memory. The cache is put between CPU and the main memory. Communication performed between CPU and the cache is word transfer, but between cache and the main memory is block transfer. When processor attempt to read words of the memory, it will check if the word is in cache. If have the memory that needed in cache, then it will deliver to the processor. If not have, the word is read into the cache and then delivered to processor.
Cache memory is utilized to decrease the normal chance to get information from the main memory. It is also a very quick memory type that goes about as a support among RAM and the CPU. It holds much of the time-mentioned information and guidelines with the goal that they are quickly accessible to the CPU when required. There are three kinds of cache memory mapping. First, direct mapping. Second, associative mapping. And last one, set associative mapping. First, direct mapping. In a direct map cache, the cache entries are organized into a number of sets. The set number from the address is used to index each set of entries. Once the set is identified, the cache tags are compared. If they are matched, this is a cache hit and the specific data is output. Second is associative mapping. A fully associative cache is the opposite of a direct mapped cache. Instead of multiply sets containing a single entry, fully associative cache have multiple cache entries, all contained in a single set. Thus, the set number no longer provides any information and is not used. Instead, when a memory address is handled by the cache, every cache entry is checked for a matching tag. If found, the byte offset is used to output the correct data with the cache block. The last one is set associative mapping. A set associative cache offers the best of both worlds. It consists of multiple sets with multiple cache entries per set. First, the set number allows the cache to jump to the appropriate set of entries. Next, each set of entries is searched for a matching tag. If found, the byte offset is used to output the request data. This approach allows the cache to offer an optimized balance of power consumption and contention rate.
Today I will explain about cache operation. First, cache will start. After cache start, it will receive address RA from CPU. After that, each block containing RA in cache. It has two conditions. If yes, fetch RA word and develop the CPU, and it will stop. If no, access memory for block containing RA will go allocate cache line for main memory. After that, add the load memory block into cache line or the next. I will explain about cache organization. Cache organization have processor, cache, address buffer, data buffer, and system bus. All these are connected to each other. As we can see, cache will go to processor with data control and data address. Data address will connect to address buffer, and address buffer will connect to system bus. And system bus will connect to data buffer, which it will send the data to processor.
Cache memory has divided into two, primary memory and secondary memory. I will explain about primary memory first. So basically, primary memory holds only those data and instructions on which the computer is currently working. It has a limited capacity and data is lost when power is switched off. It is generally made out of semiconductor device. These memory are not as fast as register. The data and instruction required to be processed resides in the main memory. It is divided into two subcategories, RAM and ROM. These are the characteristics of the primary memory. The first one is these are semiconductor memories. Number two is it is known as the main memory. Number three is usually volatile memory. And number four is faster than secondary memories. Next is secondary memory. This type of memory is also known as external memory or non-volatile. It is lower than the main memory. These are used for storing data or information permanently. CPU directly does not access this memory. Instead, they are accessed via input-output routines. The contents of memory are first transferred to the main memory, and then the CPU can access it. For example, disk, CD-ROM, DVD, etc. This is the characteristic of the secondary memory. Number one is these are magnetic and optical memories. Number two is it is known as the backup memory. Number three is it is known as a non-volatile memory. And number four is lower than primary memory.
Next, I will present about advantages and disadvantages of cache memory. The first advantage is cache memory faster than main memory. It is because cache memory consumes less access time as compared to main memory. This is done by storing the data entries, hence the CPU works faster. So, cache memory can read a lot faster than main memory. Faster than that, cache memory also stores the program that can be executed within a short period of time. It is because cache memory holds repeatedly used data which is likely to use the next, and it is faster than RAM since it on the same chip as processor. This will reduce the need for repeated slower memory retrieval for memory, which otherwise keep the CPU waiting. The more cache in the CPU, the less time computer accesses slower memory so that program can run faster. Next, I will talk about disadvantages of cache memory. Cache memory is very expensive. The more cache memory a computer has, the faster it runs. It's more complex chip that require high performance. Cache memory is too hard to manufacture than RAM. That is why cache memory very expensive. Other than that, cache memory size is limited. Cache memory need to be much smaller than main memory because it is to be close to the processor, so it has less storage capacity. Increasing the size of also may lead to latency and failed attempt to read. This is the reason why cache memory is smaller in size.
Finally, two-level memory is critical for transferring data. These two hardest computer hardware such as a monitors, keyboard, mic, and so on. Without cache, the computer may suffer from lag or malfunction. As a result, good cache performance is critical because it allows the computer or other device to run smoothly and without delay. The best cache memory perform is a 3x4 miss rate and 3x4 miss penalty and 3x4 hit time. Clearing unused cache via device setting or a clear edge is one way to improve cache memory performance.